Hello students, I am Dr. Anita Sharma. Today I am going to explain an important topic of coordination chemistry, that is trans effect. And with the help of trans effect, we easily can understand substitution reactions in square planar complexes of platinum. So let's begin. Coordination chemistry, paper 302, semester 5. Today we are going to learn trans effect, and why trans effect is important, because other topics of this unit is based on this topic only, like theories of trans effect and applications of trans effect. It is observed that during substitution reactions of square planar metal complexes, some ligand preferentially direct the substitution trans to themselves. The choice of leaving group is determined by the nature of ligand trans to it. So, trans effect can be defined as the effect of ligand over the rate of substitution of another ligand position trans to it in a square planar complex. That we will understand here. This is the example of square planar complex where T is the trans-directing ligand. So, where this nucleophile will be attached, that will be decided by these ligands. So, the ligand which is having maximum trans effect means to make the other metal ligand bond labile which is placed trans to it. So here the trans effect of this T is maximum. When we compare the trans effect of X, L and T, its trans effect is maximum. That is why this T is called trans-directing group, and it is making this MX bond labile which is placed trans to it, and the coming nucleophile will attach here. Now we understand trans effect by taking another example. This is the example of one more square planar complex of platinum. Theoretically, two reaction products are possible. When this compound undergoes nucleophilic substitution reaction, we can get either this compound or this compound. Here you can see this is cis product and this is trans product. But practically we get only trans product. We do not get this cis product. So we will understand why can't we get this, why we are getting this product. Here when you see the ligands Cl, Cl, Cl and NO2. So there are two types of ligand. The ligand which is having more trans effect. More trans effect means the tendency to make other metal ligand bond labile which is placed trans to it is called trans effect. So here the trans effect of NO2 is more than Cl. So chloro platinum bond, this bond is trans to this ligand, so that this nitro can make this bond labile and this bond will break, and this coming NH3 group will attach here, and we will get this trans product by nucleophilic substitution reaction. So, the formation of this trans isomer has been explained by saying that chloride ion laying trans to nitro in trichloro-nitroplatinate is replaced more easily by ammonia than either of two Cl ions which are laying cis to nitro ion. The phenomena of such type of replacement is known as trans effect. The group like nitro which control the entering of ligand to occupy the position trans to them are known as trans-directing group. So this nitro group is called trans-directing group, and this effect is first discovered by Chernev in 1926. This series is called trans-directing series. From different observation, trans series is prepared. So in this series, the groups which are placed at first are strong trans-directing groups, while here you can see Cn is the strongest trans-directing group while H2O is the weakest trans-directing group. The trans-directing series might depend upon the metal complexes and also on the incoming group Y. We will discuss an important question, explain formation of diamino dichloropplatinum complex by using trans method. So there are two methods by which we can prepare this complex. First is from tetraamine platinum complex on substituting ammonia group by chloride ions, and second method from tetrachloroplatinate complex on substituting chloride groups by ammonia. So we will begin with first method. In first method, you can see this is square planar complex of platinum. All 4 ligands are same. So their trans effect also will be same. So when this chloride attack on this compound or reacts with this compound, it gets attached over here. On further reaction of chloride with this compound, now this is deciding step because the trans effect of this chlorine and ammonia is different. So the trans effect of chlorine is much more higher. So whatever ligand plays trans to it will be removed. So this coming chlorine will attack here. So now you can see this is trans isomer is formed. Why trans isomer is formed, that we have already discussed. Now second complex. Second complex is tetrachloroplatinate, and this is second method also. So in this complex you can see in first step same, all chloride ions are same, their trans effect also same. So ammonia gets attached over here and by removing one chloride ion. Now on further reaction with ammonia, the trans effect of chlorine and ammonia we compare. So the trans effect of chlorine is more than ammonia, so that the trans effect will cause or will make this platinum chloride bond labile, either this platinum chloride bond or this platinum chloride bond. So now this coming ammonia attach here and we are getting cis isomer in this condition. So cisplatin and transplatin both we can prepare from different precursors by using trans effect. So we can explain formation of cis and trans isomers of diamino dichloroplatinum second complex or other square planar complexes of platinum by trans effect. So I conclude my lecture here. In my next lecture I am going to explain applications of trans effect. Thank you.